All right, my friends, hello, welcome back. We're going to look at part 2 of the pear deck. So again, we're still just working with our elimination method here. When I look at these two equations, I see a 2x and a 4x, and then I see a negative y and a negative 2y. And again, at this point, we just kind of choose which one we want to eliminate. Either would work. I'm going to choose my x's. So here I have a positive 4x. So I want this one to be a negative 4x. So to do that, I'm going to multiply, oopsies, this whole equation by a negative 2. And when I do that, I get a negative 4x plus a 2y equals a negative 4. And then our second equation is 4x minus 2y equals 0. Now at this point, here we have a negative 4x and a 4x, so we know, good, that's awesome, it'll work. It will cancel. But we also notice that there is this 2y and negative 2y. So let's see what happens when we add these two equations. Negative 4x plus 4x is 0. And then we have another 0. And that is equal to negative 4 plus 0, which is negative 4. Well, 0 certainly does not equal negative 4. So both of our variables canceled. So what happened here was both variables canceled, and we ended up with a false statement. So this means there is no solution, which of course means that we have parallel lines. So the last one that we saw in video 1 at the end was they both canceled, but it was a true statement. And here they both canceled, but it's a false statement. So this is no solution. Push ahead to 9 when you're ready. All right, we're still just working through solving the systems using elimination. In the top right, you're going to see there's this little box I made, or actually I found it, and you can use this to work through our elimination process. So step 1 is to use multiplication to create terms that are opposites. At this point, we have a positive 3x and a negative 3x, so we already have opposites. So we can go to step 2, which is add the equations vertically. 3x plus a negative 3x is 0. 5y plus 2y is 7y. And negative 9 plus negative 5 is going to get us a negative 14. So now we did 1, we did 2. Now we're going to solve for the first variable by dividing both sides by 7. And we get y equals negative 2. Beautiful. Step 4 is to solve for the second variable, and we do that using substitution. So I'll pick the first equation, which is 3x plus 5y equals negative 9, and I'm going to plug in negative 2 for y. So we have 3x, 5 times negative 2 is a negative 10. So we have 3x minus 10 equals negative 9. Then I'm going to add 10 to both sides, and I get 3x equals negative 9 plus 10 is 1. And then divide both sides by 3, and we end up with our final answer of x equals 1/3. So we have this coordinate, which is at 1/3, comma, negative 2. And that's our final answer. Push ahead to slide 10 when you're ready. Take your time, get all the notes that you need. At this point, we already have terms that are opposite. right, we see this negative 4x and this positive 4x, so we can get right to adding. Negative 4x plus 4x is 0. Negative 8y plus a negative 3y is a negative 11y. And 12 plus 10 is 22. So then we're going to divide both sides by negative 11 to get y alone. Negative 11 divided by negative 11 is just 1. So we have 1y equals 22 divided by negative 11 is a negative 2. Perfect. And then we can choose either equation. I'll choose the second one, which is 4x minus 3y equals 10. And I'm going to plug in my y value as negative 2. So we have 4x minus 3 times negative 2 equals 10. Negative 3 times negative 2 is going to get us a positive 6. And then when we subtract 6 on both sides, we get 4x equals 4. And then divide both sides by 4 to get x equals 1. So we have our full coordinate, which is at 1, comma, negative 2. We have 2 more problems like this that we are going to do together. When you have everything that you need, push ahead to slide 11. Use multiplication to create terms. Luckily, again, we already have them. So we have a 6x and we have a negative 6x. So we can go ahead and just add these two equations. 6x plus negative 6x is 0. 9y plus a negative 8y is just going to be 1y equals negative 6 plus 2 is negative 4. So I have our y value of negative 4. I'm going to take my first equation, which is 6x plus 9y equals negative 6. And I'm going to plug in negative 4 for our y value. So we get 6x, 9 times negative 4 is a minus 36, is equal to negative 6. To get rid of this minus 36, we'll use inverse operations, and then we get 6x equals 30. Negative 6 plus 36 is positive 30. And then we divide both sides by 6, and we get x equals 5. So our coordinate, is 5, comma, negative 4. Beautiful. Last one on slide 12. This says Lonnie has 18 bills in his wallet, and he only has singles and $5 bills. The value of the money in his pocket is $46. How many $5 bills does Lonnie have? So X is the number of singles, Y is the number of $5 bills. So we have to write 2 equations, and then we're going to solve it. Now, the first equation is the total amount of bills, right? X is the number of singles, and Y is the number of $5 bills. Of all the bills, Lonnie has 18 in total. So one equation we have is X plus Y equals 18. Another equation is we also know that he has $46. So 1 times every single bill plus 5 times every $5 bill is going to equal $46. Now we have our 2 equations here. So we can use multiplication and multiply this first equation by a negative 1. And when we do that, we get negative x minus y equals a negative 18. And we're going to add that to positive x plus 5y equals 46. So when we add these two equations, our x's cancel, and we're left with 4y equals negative 18 plus 46 is 28. And then divide both sides by 4 and get y equals 7. So what that means is there are 7 $5 bills. And then if we take that 7 for y and plug it into either equation, let's plug it into our first one, which is a little simpler, x plus y equals 18. But now we know that y is 7. So when we subtract 7 on both sides, we would get x equals 11. So this means that we have 11 $1 bills and 7 $5 bills. 11 plus 7 gives us 18 bills in total, and then 11 times 1 plus 7 times 5 would get us 11 plus 35, which is in fact $46. So we checked our answer and it works for both of the equations that we made. Beautiful. Hopefully you are feeling confident on elimination. If you need any help, reach out to me, send me an email, let's talk, let's do it together. Before you finish this video, I want you to take a second to think about what dog fits your feelings today. You can circle, highlight anything, and then there's some open space, so if you have a message you want to share with me, if you want to request a time to meet, feel free to put anything in that blank space right there, okay? Take care of yourselves. You all rock, you're geniuses, and I will see you in the next video. Bye, everyone.